Good afternoon, all. We can start our session within 5 minutes. We're waiting for others to join.
Okay, let's start our today's session, Fundamentals of GIS. So it's my pleasure to introduce Mr. Rajan M., scientist at the Geospatial Science and Technology Division. Mr. Rajan has extensive research experience in diverse areas, including watershed development, natural resource management, coastal and environmental studies, climate change, disaster management, and local level spatial planning. He earned his master's degree from Kannu University and has been actively engaged in applying geospatial technologies to address environmental and developmental challenges. He has contributed significantly to numerous projects and training programs of the division, particularly in the areas of Earth observation data, GIS, and geospatial technologies. His work focuses on leveraging geospatial tools for resource management, environmental monitoring, and sustainable planning. With his expertise and practical experience in geospatial science and technology, Mr. Rajan brings valuable insights to this faculty development program. Let's extend a warm welcome to Mr. Rajan M. and invite him to share his knowledge and experience with us. Sir, please, sir, hand over to you and welcome to the FDP. Sir, we are audible. Sir, you can start now.
There is an issue in the audio. So participants, please wait. നേരത്തെ പറ്റിയില്ല.
ഇപ്പൊ കേക്കാവോ? ഹലോ, ഓഡിബിൾ ആണോ? സർ കേൾക്കുന്നുണ്ടോ?
Sir, we can hear you. Sir, please share your screen.
ഓക്കെ. വെയിറ്റ്. പിന്നെ ഒരു മിനിറ്റ് ആണ്, ഇത് എൻ്റെ സ്ക്രീൻ ഷെയർ ചെയ്യുമ്പോൾ ഇപ്പൊ കേക്കാവോ? കേക്കുണ്ടോ? കേക്കുന്നുണ്ടോ? വെയിറ്റ് ചെയ്യണം. ഇപ്പൊ കാണുന്നുണ്ടോ?
സാർ സ്ക്രീൻ ഒന്ന് ഷെയർ ചെയ്തോളൂ സാർ.
ആ സ്ക്രീൻ കാണുന്നുണ്ടോ?
സ്ക്രീൻ കാണുന്നില്ല.
ഇല്ല. Wait. അങ്ങനെയല്ല, ഒരു മിനിറ്റ്. ഹലോ പക്ഷെ മേഡം അതിന്റെ ഇതുവരെ കാണുന്നില്ല എനിക്ക്. ഒരു മിനിറ്റ്.
പറയൂ സർ.
അൺമ്യൂട്ട് ചെയ്ത്.
ഇപ്പൊ കാണുന്നുണ്ട്. സൗണ്ട് വരുന്നില്ല.
ബോർഡർ ലെഫ്റ്റില്
നമ്മളിവിടെ
ഇപ്പൊ കേക്കാവോ? സ്ക്രീൻ കാണാവോ? താങ്ക് യു. Good afternoon. I'm Rajan, I'm scientist at IRTC Mundur Palakkad. I'm honored to be a resource person for this FTP program organized by Civil Engineering Department, CMAT. I sincerely thank CMAT team for providing me this opportunity. I wish you all the best for the program. I look forward to sharing and exchange knowledge with you all. Now let's begin our section. Topic is today, topics Fundamentals of GIS. So what is GIS? GIS is a geographical information system. Combination of geography and information system is GIS. Okay, geography is a scientific study of Earth and its pattern process. The information system is an interactive combination of people, computer hardware, software, and combination devices and procedures. Definition of GIS. ISRI, the Environmental System Research Institute, defined GIS is a organized collection of computer hardware, software, geographic data designed to efficiently capture, store, update, manipulate, analysis, and display all the form of geographically referenced information. So this is the definition of GIS by ISRI. That is a capturing. Data capturing means we have to capture data in the form of images like satellite imagery, aerial photos, drone imagery, maybe scanned imagery. And the next is store. We have to store that imagery into our system. Okay, system, and we have to do many process updating, manipulating, analyzing. So we will use software tool for updating and manipulating. After them updating, we have to do analysis, and finally we have to display the GIS data in different form. So GIS is simply is a digital mapping. Okay. Or GIS, that means we are preparing map. Okay, that's a digital mapping. Then with the help of computer using software, we will prepare maps. That's simply as a GIS. The history of GIS, as we know that history of map is when we talk about the history of map, thousands of years, many Romans, Arabs, Greeks used it to prepare map to for their traveling purpose, used it for traveling purpose. And later on, after the computer revolutions, 1960 era of quantitative geography started, and then Roger Tomlinson, a Canadian geographer who prepared one land capability and land use classification for rural Canada in 1963. That widely used for development of Canada. So he also developed as a CGIS, Canadian Geography Information System. That's why we are considering Tomlinson as a father of GIS. In 1964, in state like in USA, state like Ottawa, Ontario, Department of Energy and Mines Resources prepared map of Ontario, just like a resource map, okay, mining map, okay, for that widely used for their planning purpose. And then Charles Pickett, another one geographer, prepared map for cholera outbreak in Paris 1964. That widely used for health purpose. So that means GIS is a tool. Okay, everyone can use GIS. Okay, even social science background, the person who has from social science background, science background, okay, commerce background, everyone can use GIS as a tool. Okay, in 2020 November 18 is a celebrated GIS Day. Next is advantage of GIS. Why GIS? What is the importance of GIS? Okay, so GIS is an improved decision making. Okay, improves decision making. Okay, just to assume. Okay, we are living in a village. Okay, in a micro watershed, inside of one micro watershed. So we are going to we have planned to prepare a pilot project based on soil survey and soil conservation, soil and water conservation treatment in your micro watershed in your village. Okay, so what are the treatments we will consider? First one is a contour bund, okay, mud bund, stone bund, and also rain pit. Okay, rain pit. Then because rain pit, which is a primary treatment, okay, consider the main object is to enhance the groundwater recharge and reduce water scarcity in your village. Therefore, task is to identify suitable locations for implementing rain pits. So how can identify the appropriate locations, area for digging or practicing the rain pit? First, initially as a common practice, one may conduct questionnaire based survey by visiting each household and collecting information with the help of house owners. However, traditional method has several limitations. Okay, there is a possibility of manual errors such as missing respondents. When if we go into if volunteers go visit this house in any house, then missing the respondent when house are locked or occupants are unavailable. In such cases, data may be filled based on the assumptions. Okay, this process is to also time consuming and require additional cost for deploying volunteers to visit every household. In contrast, in GIS technology, we can develop identify the appropriate areas for practicing rain pit. How is possible? Then that means when we what are the main parameters we will take into consideration for constructing or practicing rain pit? First one is slope map. Slope, okay, slope. When talk about that slope, there is a many slope. That many slope can be classified as a steep slope, moderate slope, a gentle slope. Okay, low-lying area, paddy field. Okay, is it possible to practice rain pit in a steep slope area? No, that's not possible because close to the landslide. Okay, and what about the moderate slope? Yeah, that's okay. Okay, we can practice rain pit in the moderate area, moderate slopey area. And in the gentle slope and in the case of the paddy field, the low-lying area, that's impossible. Okay, because that will be create a flood. Okay, cost for flood. Okay, so the appropriate location based on the slope map we identified the moderate slope is good for practicing the rain pits. Okay. Next, can we practice rain pit in all the moderate slope? Is it possible? No, because in the moderate slope there will be many buildings. Okay, there will be a settlement area. There will be a road transportation activity, and also their water bodies also. So we will take one more parameters like land use for this consideration. Okay, to identify appropriate rain pit areas. So when we that take the land use map, then there will be many that we will take the plantation area alone. There is a coconut plantation area in our village, that is large area as a plantation. Okay, rubber plantation there, cashew nut plantation. So we will take all the plantation area are appropriate for the practicing rain pits. Okay, based on this slope map and land use map, we finally we identify the appropriate area for practicing or implementing rain pit. Okay, and after that we will calculate the area very quickly, and finally prepare the estimation based on the data, and okay, and you can prepare pilot project report. Okay. Next one is reduce cost and increase efficiency. Means I already mentioned, okay, that when we go to field, okay, visit every houses, we have to we need time, more time to complete. Okay, and also have to meet some other we need money to pay volunteers. Okay, so that's one is okay. Next thing is easy record keeping. That means as a computer's tool, we can record all the information. Okay, every information in your system. Okay, example, we are taking one panchayat. Okay, example cadastre map or cadastre map, that is village map. There's village map, 5,000 scale, large scale map available in village. Okay, we take the village map and we just to displaying the village map, we need one classroom. Okay, to display that all the map. Okay, but in the case of what about the Ender Palakkad district cadastre map, so we need much area to display the Ender cadastre map of the Palakkad district. This is impossible. So in the case of that the computer tool, as we can display all the data set as all. Okay, that's the main thing of that. The next one is managing geographically. Means we can manage geographically. That is, we are always using Google Map. Okay, that if you going any visit any places, then if you plan to visit many places, then you will identify that is from here to destination, what the distance, okay, from to there, and how long will be take, and how far from here to there. All things will be available using the Google Map. Okay, that things is managing geographically. Okay, the improved communication between organization. Means we have many department in Kerala. The example, Kerala State Land Use Board who are preparing digital map. Okay, using GIS software of entire Kerala land use. Okay, panchayat wise available in their department, and also geology departments there, groundwater bodies there, soil survey, soil conservation departments there. They will prepare a map of soil map. Okay, every department using the GIS as a tool for preparing their own data set. Okay, and generating their own database system. So what is the problems that they are not sharing? Okay, there is a many restrictions to share all the data, so they are keeping. Okay, but in the case of America, US, they are sharing data, everything in the website. Okay, they will host a website, then we can download it. Okay, that will be I hope possible everything later on. Okay, in the future. Next, come to the GIS data. GIS data we can classify it into spatial data, non-spatial data. Okay, GIS data, non-spatial data, spatial data. Okay, what is spatial data? Spatial data is a that is a geographical location associated with it, and the spatial data stored in a coordinate that has a topology. Okay, it has a physical representation. It's a shape, size, and orientation. Example, Jammu Kashmir. When we talk about Jammu Kashmir, one thing comes in mind, that Jammu Kashmir, the visible map, okay, that is the northernmost state of the India. Okay, it was a northernmost state. Okay, so that's a orientation. That their Jammu Kashmir has its own shape. Okay, that is a shape. Okay, that shape and the orientation, size. Okay, that's linked to the coordinate, linked to latitude, longitude. Okay, that means just spatial data is a map. Okay. But what about the non-spatial data? Non-spatial data's information with respect to spatial data, with respect to that map. Okay. So in GIS, there is not only one map, but also there is a information that will be recorded in a table. Okay, that will be recorded in a table in a Excel sheet. That is attribute data. Okay. So example, in Jammu Kashmir, the table, we will create one name of the state, Jammu Kashmir, and the number of the district and number of the panchayat and etc. All the information will be added in a concerning that attribute table. This is spatial data. This one is spatial data. This map, okay, the Kerala map. Then this is non-spatial data, combining of GIS data. Both together as considers GIS data. Next one is types of spatial data. Spatial data is a map, right? Okay, two types map is available there for in GIS. Raster map, raster data, vector map, vector data. But what is raster data is, raster map is that data shows in a cell. Okay, pixels. Okay, each pixel has a value having representing spatial features. Okay, example, this one is raster data. I'm taking a small area and enlarged it. Then we can see all cell in this, all in a cell. Okay, that's in a pixel. Okay, so we can visualize this pixel as in color. Okay, example, this one green color, dark green color indicates rubber plantation, light green color representing coconut, blue color indicates water body, red color build up plan. But system will record in its color numbers. Okay, that blue color 00100 number and green color 111 test like that. That's raster data structure. Okay, well, what are the raster data types? The satellite imagery, DEM data set, drone imagery, aerial photos, scanned imagery, graphic files, all different types of raster data. So next one is popular raster file formats are normally PNG, TIFF file, GeoTIFF file, VRT file, then SRT file, DEM file, and so everything SRTM file. This is all the file example for the raster file format. Next one about the vector data. Vector data that represent in a XY coordinate are locally known as vector data. Example, we got one imagery of one Grama Panchayat. Okay, satellite imagery, just Sentinel or Landsat. That is a raster data. Based on that raster data, we will develop or we will create another data set. Okay, that is vector data. So data which are developed or generated from the extracted from the vector data is raster data is known as vector data. So all the digitized maps are example for vector data. Example here, the vector data here is 3 view unit. There is 3 trees are there, individual trees. So that will be recorded at a single point. XY means latitude, longitude. But in the case of that one stream is passing out there, flowing there, then that will be in elongated feature. So there that is a many latitude values, and another one is a closed feature, that water body dam, that will be closed. Okay, this one is vector data, this one is raster data. Below one is raster data and above one is vector data. This is one imagery, okay, Google imagery. We can see trees there, one road passing over, one stream there. Okay, so with respect to that, we are preparing vector data based on that raster data, just like the blue color indicates stream and yellow color road. But what the file format for vector data is shapefile. Very important thing is shapefile. In GIS, shapefile is very important file format, and KML file that will be work equal markup language, that will be work in Google Earth. Okay, Google Earth GML format also, and card file, Corel Draw, AutoCAD DX file, everything, Tigger file, and all the files are example of vector file format. Next one is types of vector data. So we can digitize or delineate or prepare map with using the base map. Okay, with using the base map, raster map, in three format. Okay, point feature as a point feature, line feature, and polygon feature. Okay. Point feature data exit when features are set with a single location. If it's a if we want to represent single point, individual location, then we will use the point feature. Example, in your village or Grama Panchayat, we are going to prepare map. Then features like asset, landmark, wells, etc. will be digitized in a point feature. Here all the capitals of and all district in the Kerala representing in a point feature. Next one is line feature. Line feature is a linear feature. Linear feature starting here, ending another part. Okay, so that will be linear features, elongated feature. So the stream, road, railway line, then electricity line, then pipeline, okay, etc. We can represent in a line feature. Here in Kerala, we are representing all the streams in Kerala in a line feature here. About the polygon feature is a closed feature. Okay, closed feature starting and ending at the same point. So land use map, administrative map, okay, spawn bond map, then slope map, soil map, geology map, geomorphology map, etc. representing in a polygon feature. If we want, we will get the area of the polygon feature if we digitize in a in polygon feature. If we digitize one feature, digitize in a polygon feature, then we will get the area of that feature. This is the result of the polygon feature. Administrative map of Nilamur Block Panchayat. The different Grama Panchayat represent different color here. Next is components of GIS. As we know that there are many components. GIS as a component like hardware, software, mobile app, people, okay, user also, and data set. Then about the hardware, as we know that hardware, everything included. In the case of software are generally classified in two, okay, based on the availability, free software, open source software, proprietary software, paid software. Free software that we can use to study, modify without any restriction, which can be copied, redistributed, modified, unmodified form, many without charge. Okay, so can have a fee. Example that many open source software like GraphGIS, QGIS, SagaGIS, Map Server. About the paid software, which is neither free nor open source, copyright owner, is a closed source software. It has restrictions. Okay, so in GIS, ArcGIS, MapInfo are example of paid software. Next one is map and scale, okay, because GIS is a digital map, okay, digital mapping. So we want to know the definition of map. Okay, map is a true definition, true representation of Earth as a whole or part of it on a plane surface. Okay, that means 3D to 2D conversion. Okay, the scale is a ratio between map distance and ground distance. Map based on its scale classified as small scale and large scale. Small scale means covering large area, but information is less. But about the large scale, covering small area, but including more information. Example here, this is map of Thrissur city, 1:25,000. So this is blurred, right? So we can't identify the features clearly in this image. It's blurred, but in 10,000 area reduced, okay, and features are visible clearly. But in the case of 5,000 area reduced more, and more information can be identified. Okay, so which one is large scale, which one is small scale? 2,500 and 5,000. 2,500 large scale, 5,000 as compared to 5,000 small scale, 2,500 large scale. Okay, 10,000 is small scale map as compared to 5,000. 5,000 large scale, 10,000 small scale, like that. Then come to the map projection. Map projection is very important thing. Okay, map projection is a parallels of latitude and meridians of longitude. Okay. Commonly in a manner map making, there is a many projection system: conical, cylindrical, polygonical, azimuthal, etc. But in digital mapping, we will consider UTM projection. That is one of the Mercator projection system. UTM projections. UTM projection is Universal Transfer Mercator projection. UTM projection is a system assigning coordinate to location on a surface of Earth. It's a traditional method lat launch and corresponding representation. UTM system divide Earth into 60 zones, each 60 longitude in a width. UTM projection is worldwide accepted projection. It commonly used in GIS by every country. Okay. And come to the datum. Datum is a mathematical model that approximate the shape of Earth to enable accurate position, length, and area calculation. There are many datums available. WGS 84, World Geodetic System 1984. That is worldwide accepted datum. Datum are two type. Okay, global datum available, local datum available. WGS 1984 is a global datum, so every country can use that datum. The local datum NAD, North American datum NAD 83. That can be only used for mapping the area inside of the North American. Datum, another one is datum is a reference from which all the measurements are made. The two datum type is available: horizontal datum and vertical datum. Horizontal datum is describing the point on Earth's surface, that is latitude, longitude. Okay, vertical datum is to measure the elevation, elevation from the mean sea level and underground depth. Everything comes under the vertical datum. So WGS 1984 43 North is datum using when preparing map in India. This is UTM zone numbers. Okay, UTM zone numbers. Actually, this is a map. Okay, map is a true representation of Earth as a whole or part of it on plane surface. That is in a plane surface. That is this map. Okay. So world map. This is world map. There is a horizontal line. There is a many vertical line. Okay. So horizontal lines. The horizontal line here 0. The Earth divided into two half, that by the 0-degree equator, north part is northern hemisphere and south part is southern hemisphere. Okay, 0 degree. Okay, 0 degree and up to 90-degree north pole and south 90-degree south pole. Okay, so total degree 181-degree latitudes are available. Latitudes, equator is a latitude. Okay, longest latitude. So all the vertical lines are latitudes. And about the horizontal, all the horizontal lines, all the horizontal lines are latitudes. 0 is the 0. The equator is example for the latitude. Okay, the vertical lines that connecting both poles, north pole, south pole, north to south, that is vertical line. That all longitude. Okay, unlike the equator divided Earth into northern hemisphere and southern hemisphere, there is another line here, central meridian, Greenwich meridian. That is a longitude passing over London. Okay, Indian Standard Time that considered based on that central meridian. So based on the central meridian, Greenwich meridian, we can classify the eastern part is eastern hemisphere and western part is western hemisphere. Okay. So these all things. So I am talking about latitude longitude of my own area, my location. Okay. So I am telling the this much degree minute second. Okay. Lat launch represent in a unit like degree minute second. This much degree, this degree minute second. Okay. Or decimal degree. Decimal degree means degree plus minute divided by 60 plus second divided by 3600. That is formula using for converting degree minute second into decimal degree. Okay. So I am standing in India. So I will tell my latitude, this much degree, this much minute, this much second north latitude, and this much degree, this much minute, this much second eastern longitude. But if I'm standing on Australia, I will tell my latitude is southern latitude and eastern longitude. If I'm standing my location here in Northern America, so North America, there I will tell the my latitude is northern latitude, but my longitude is western longitude. Okay. So next one is UTM zone. UTM zone is Earth divided into 60 zones based on the 6-degree longitude interval. That means 6 degree here, 0, 60, 12, 24, 36, up to 180, up to 180, 360 longitudes available based on degree. Okay. So here here in the northern side, that northmost side, the top side, there is a 1, 2, 3 up to 60. This is all the UTM zone. So India situates in between 41 to 47 UTM zone. Okay. About the Kerala, Kerala locates inside of the 43 north. When preparing map of the Kerala, we will add the 43 north zone. That already mentioned WGS 84 43 north north. Okay, but in the case of Tamil Nadu, that comes under 43 north as well as 44. Okay, it's up to Salem 43 and Chennai region, that's a 44 north. That is a zone number, UTM zone number. talk about topology is very important thing while preparing map. That is a topology is describe the spatial relation between adjoining feature. Okay, topology actually automate way to handle digitization editing errors. Topology reduce storage and ensure quality. Topology is a very important ensure quality. Okay, so that is topology. I will explain through the example. Example, topology spatial relationship. That is adjacency. Adjacency means here A plot here, B plot is there. Okay, A plot, B plot. We are mapping two adjoining plots. Okay, A plot, B plot. So there is a common boundary in between A plot and B plot. That is adjacency. Okay, that is a polygon feature. In the case polygon feature, but in the case of line feature, one road is there, another road is joining in with that road NH. Okay, one NH passing there, another SH road joining with the NH. That is a connectivity. Okay, containment means there is a paddy field. Okay, that is a polygon representing a polygon. That inside of that paddy field there is a one point that also be representing in a polygon feature. That is containment. Okay, containment, one polygon inside of one polygon. We need to understand topology error. This is common error occur while digitizing map. Okay, dangle error, there is a gap in between, switch back error, not error. This is all occur while digitizing or preparing map. Okay, gap, there is a gap error and silver polygon occur when digitizing one to adjoining polygon feature. There is a gap occur, that's a gap polygon error. Then exceed over another one, that is silver polygon error. This is undershoot overshoot error. I already mentioned there is a one NH passing over there and another SH road. Okay, another join with that road. If there is a gap in between, that's undershoot. If you exceeded over another one, that is overshoot. So we have to rectify all the error after digitization. Okay, that is topology error. Next part is processing GIS. That means how to prepare, how to generate digital mapping, what are the process steps we should follow while preparing digital map. First one is example, if we get the data from the satellite imagery or aerial photo, drone imagery, that's fine. Okay, first two things will be excluded or avoided. Okay, but if we want to prepare land use map of one panchayat, then we are not using the satellite imagery. We visited one panchayat, okay, and collected land use map prepared by land use board. Okay, that will be then we have to do scan it. Okay, first scan it and then import the scanned imagery into the software. After install the software in your system, a laptop, then you have to import that imagery into your software. Okay, that either QGIS software, ArcGIS software, mapping for anything. Okay, so that will be imported in a QGIS platform. Then after the imported imagery, that we have to do another thing, geo-rectification. Okay, so what is geo-rectification means? Geo-rectification is assigning coordinates into the map. Okay, we have to bring the map into the location platform. That's converting into unproject location to projector location. Okay, so why should do the geo-rectification? What is need of geo-rectification means if we want to do analysis. Okay, there is a number of analysis available GIS. platform, then if you want to do perform any analysis, then you have to do georectification, just like area calculation, length measurement, buffer analysis, everything we have to do. We have to do the georectification process. Okay, and also if you want to import, if we want to open or display your study area map or your map that you generator, then that have to import into the Google Map platform. Then you have to do the georectification process. Okay, so for georectification we need at least 4 points. Okay, what point? Latitude, longitude of non values. So initially we have a scanned imagery, so we should identify at four non points. Okay, non points. Example, non points means there is two roads joining there, junction. One road is there, another stream passing over, then there is a bridge. Okay, another side, if we taking the southern part, example, we need 4 points, so we are taking 4 points in a specific area. That's not good. We have to cover all the ender panchayat, all ender imagery. So we were taking southern side point. Okay, there is a one the southern side, one tour passing over, then there is a junction. We are taking lat longe value. You use either mobile phone or GPS, or you can use the DGPS. So when using the mobile GPS, we will get 5-meter accuracy value. Okay, if we are taking the GPS data, that will be in a 3-meter accuracy. Okay, the 3-meter accuracy means what the value we are recorded, that will be inside that will be what I say, differ from the 3-meter from actual point. Okay, 3-meter difference from actual point. So, but in the case of DGPS, differential global positioning system, we will get details less than 1 meter, 0.5 meter, 50 centimeter, 60 centimeter accuracy level. So we are taking 4 points. So I'm going to southern point, then taking the value, then going to the western side. There is a one road and stream, and then bridge. They're taking that point. And northern side there is a building. I'm taking 1 point. Another side I'm taking the same. Like that we are taking 10 point, at least 10. We will take 10 more points. Okay, additionally, and we will add all the points, and after the process we have to choose 4 points alone. That is with the less RMS error value points. So after georectification, we will start to digitize. Okay, digitization. So what is digitization? Is a drawing process. Okay, using mouse. Okay, we are drawing map. Okay, drawing the map using mouse. That is digitization. Okay, so we are going to digitize features. Okay, so your study area, that panchayat. Okay, we are taking one panchayat, then we will prepare panchayat boundary as a polygon. Okay, then next one is, another one is inside a panchayat there is a many point feature. Okay, point features, then just like asset and landmark. So we are taking all the asset in a separate layer as asset. Okay, as a point, then landmark as a point, well details, data, everything recorded in a point feature, and it stream in a separate line feature, road in a separate line feature, because stream, road, both are line features. So we have to represent both are separately. Okay, so we will digitize all the layer. Okay, all the layers, land use map as a polygon, slope map as a polygon feature. So that will be developed in a layer by layers. Okay, so then below layer is base map. From base map, from which all the layers, all the vector layers are generated. Okay, so above the base map there is a polygon that is that map layer by layer. There is analysis, spatial query analysis, overlay in model. Okay, I'm mentioning here 3 or 4 analysis. First one is buffer analysis. Buffer analysis, we are widening one road, NH road from then example Palakkad to Thrissur road. If we want to widening both side 100 meter, okay, it's either side 100 meter, okay, then we will initially we have to collect all the data. Just means all the building, we should mark all the building as a point feature. Okay, then after that then we will digitize point sorry line feature road as a polygon, then do the buffer analysis, then we can identify how many buildings comes under buffer, inside a buffer. Okay, when by road when by road, how many roads will be indicated, that all things will be identified, okay, from your lab. This is all the buffer. We can do buffer in point. Okay, we can do we can perform buffer analysis in line feature or polygon. Okay, according to your requirement. There is a buffer is available, multiple buffer. That means here is in polygon right side there is a multiple ring buffer is available. Just like 100 meter, then next one is a 200 meter, 100 meter, next is 300 meter, next is 500. Just like you can give the intervals accordingly. Next one is overlay operations. Overlay or task to rain pits. Okay, identify the appropriate location, appropriate area to practicing rain pit in your village. In that case, slope and land use map are taken into consideration. So the same method, that example of overlay analysis. So we can do overlay using more than 2 layers. So suitability of land for successful collection of black bears, that we can do many land suitability analysis. The just the drainage density map, transportation map. So we can add all the layers together and identify and giving the weightage, okay, priorities based, and finally I identify the suitability of land reallocation. Next one is spatial query analysis. Spatial query analysis means if we are going to your task is your project is based on the wetland map. Okay, so I'm sharing one land use map of one Grama Panja, your study area, one land use map of your study area. Then you want to extract the wetlands, paddy and a paddy field, and the land with respect to the paddy, that paddy converted to other crops that like previously. That all the paddy converted wasteland, paddy converted plantations, mixed crop, everything comes under the wetland. That so you can extract the wetlands alone from the entire land use map. So that is spatial query analysis. TIN model is a actually tin model, that triangular irregular network model that will be developed with the DEM data, okay, digital elevation model. So we can download it as DEM data, that's SRT DEM, Cartosat DEM from the website that's available freely available from the site. Okay, Copernicus site, then USGS site. You can download it, the DEM data, and you can develop the TIN models with respect to that using that DEM data set. That is most useful for studying the highland areas. Okay, mostly. Okay, just that TIN models can be useful for identifying the landslide area, and also to identify the flood prone area also. That's a triangulator irregular network model. After analysis, we have to compose the map. Okay, we have to prepare map. Okay, so after we have to compose the map. So as a composing one map, okay, for attaching with you, your report. Okay, for attaching with your report. So there is a many elements map. Okay, so we have to we want to add some elements, that title of map, that indicating what is with actually with that map indicates. Then we can add the subtitle. Okay, example title land use land cover map. Okay, then subtitle Palakkad district or Mundur Grama Panchayat, like that. Then we have to give the north arrow. Okay, we will add the north arrow, and we have to add that scale. Okay, scale below there in a statement or in a fractional as a desired format. Then next one is we have to add the legend type also, legend. Okay, then a legend that will be shows all the keys. Okay, index of the that all the features. Shows in a different colors and different symbol, using different color, different symbol. That's all about the legend. And finally, we will add the grid system, latitude, longitude grid system, latitude grid, and then finally import into the, save as JPEG format, or TIFF file PNG format. Thank you. Hello? Hello? Audible?
Yes, sir. You're audible.
Madam, my section over. Sorry to interference. Hello? Interruptions.
Yes, sir.
Starting. Okay. Actually, first time I'm actually, it's my first class online, so some interruption. Here is a network trouble occurred. Sorry, really sorry. And if you have any clarification regarding this topic, ma'am, you can frankly ask him.
Participants, if you have any queries, you can ask.
So if you need any clarification regarding any topic, I can explain. I am always ready to explain.
Okay, sir. We will unmute the participants now.
Okay.
Participants, if you have any doubts, you can please clarify it now. We have unmuted. Okay, sir. I think there is no queries.
Okay. Okay.
Thank you, sir. The session was very wonderful and informative.
Okay. Thank you.
Okay, thank you.
Okay. Thank you so much. Thank you. Thanks, everyone.
Thank you so much, sir.
Thank you, sir. Thank you.
Participants, feedback form will be shared shortly. Kindly fill it. And tomorrow session, we will start tomorrow morning, 10 o'clock. So thank you. You may leave the session now.